All right, we're looking at indefinite integration here, or indefinite integrals. And this is approximately section 4.6. And before we get started on that, number 16 in 4.6 is a little difficult until you realize that sine of 2x, which is part of the expression, is equal to 2 sine of x times cosine of x. So use that identity to rewrite sine of 2x this way, and then things will reduce, and you'll be able to deal with it. Right away, you should notice that something is missing here. And something that's missing is our limits. When we have limits of integration, we're talking about an area under the curve between whatever those two limits are. When we don't have limits, we have what's called an indefinite integral. With limits is definite, without limits is indefinite. And what we are after here is just what is the function whose derivative is this? We're really just after the antiderivative. So it comes after definite integrals in the text, I think because integrals are derived as the area under the curve, which sort of requires the definite integral. But these are less work. All we have to do is find the indefinite integral. We don't have to plug in the limits of integration. So we're actually taking a little bit of a step backwards as far as difficulty is concerned. And they're real easy. Well, except for the ones that aren't, right? I always say things are easy. If we've got a letter to a power, we know how to deal with it. Increase the power by 1. So we've got x to the 2.3. And then divide by the new power. Same thing here. The 2.5 plus 1 would be 3.5. And then we're going to divide by the new power. I apologize for the lack of readability of some of these. Because we're doing indefinite integrals, we're not plugging in the number. We do have to acknowledge that there very possibly could be a constant on that antiderivative. So we're back to including the plus c as we did at the end of the last chapter. But that's it. That's indefinite integrals. Just evaluate it. You don't have to plug anything in. Same rules apply as before. If you've got something that's more complicated than just a polynomial or a simple trigonometric expression, you got to simplify it first. So we get 3u squared plus 12u minus 4u would be plus 8u and then minus 16. Right. And then that is going to give us u cubed plus 4u squared minus 16u plus c. Okay, I don't think any of that's mysterious. We increased the 2 to 3, then divided by 3, which canceled that out. We increased the 1 to 2, divide by 2, that gives us the 4. And there we just tack on the u and the plus c. Done. This one here requires a little simplification, just like the last one. And remember that x square root is just x to the 1/2 power. So we would subtract x to the 2 power minus 1/2 would be x to the 3/2 power. Here we have an exponent of 1 minus the 1/2 is going to be just x to the 1/2. And here we're going to get 4x to the negative 1/2 power. All right, 3/2 plus 1 is 5/2. And then divide by 5/2 or multiply by 2/5. 1/2 plus 1 is 3/2, so we have x to the 3/2. Divided by 3/2 or times 2/3. And here, we're going to have x to the 1/2 plus 1 is, negative 1/2 plus 1 is positive 1/2. And then we're going to divide by positive 1/2, which is the same as multiplying by 2. So we're going to get plus 8 there. And then we'll have, of course, our plus c. And last, and possibly least, depending on how you think about it, we've got x plus 1 minus x to the, 1 over x squared. Now, if you want to think about these easily, or if you want to write them in the easiest way to deal with them, you want to write them as x to a power. So instead of 1 over x squared, write x to the negative 2. Same as when we were doing derivatives. That advice doesn't change. Antiderivative of x, that's going to be x increase the power, divide by the new power. The antiderivative of a constant is just that constant times x. And then here we are going to increase the power by 1, so negative 1. And then we're going to divide by negative 1, which is going to change the sign there. And then plus c. And if you leave it like this, I'm fine with that. You could also change that to 1 over x. You know that that's what x to the negative 1 power is. So I'll leave that to your discretion, either one. So that's indefinite integrals. Since it's actually less work and less complicated than the definite, I think if you've got the definite integrals, you shouldn't need any more work on these, but definitely practice them.